Welcome. In this video, we'll be analyzing the product of polynomials part 3. Let's take a look at our example. Example 1. Find the product 3x minus 1 quantity square. Let's recall what 3x minus 1 quantity square means. If you recall, based on the properties of exponents, we can say that the quantity 3x minus 1 square is simply the product of 3x minus 1 and 3x minus 1. Now, notice that in this case, we're dealing with the product of two binomials because we have a polynomial with two terms here and a polynomial with two terms here as well. Now, these two terms and these two terms are being multiplied to come up with the final product. So that means that once we are actually looking for an area model, we're going to have a rectangle of dimensions 2 by 2. So let's go ahead and create our area model. In this case, we can even say that this punnet rectangle, it's going to have to become a more specific one. In fact, this is not a punnet rectangle as any other. This happens to be a punnet square because both dimensions happen to be the same. Notice that here one of the dimensions is 3x minus 1 and the other one is going to be 3x minus 1. So we can say that this is indeed a punnet square of dimensions 2 by 2. Okay, once we have the area model here, we can actually go ahead and write down the dimensions on the outside. So this is going to be 3x minus 1, and this is also going to be 3x minus 1. Now, we say that this is going to become an area model because if we were to find the area of this punnet square in this case, we know that the area is going to be given by the formula base times height, or side by side for a square. So we can say that this area is going to be 3x minus 1 times 3x minus 1, or simply 3x minus 1 quantity square. So that's the actual area of the big square in this case. But we can actually find out the area of that square by finding the area of this section here, the area of this section here, the area of this section here, and the area of this section here, and adding all four areas together. So that's how we're going to approach it. So in this case, let's find out what is the area of this section. Well, we know that the base is 3x and the height is 3x, so 3x times 3x is simply 9x squared. Then we proceed to find the area of this other section here. So we're going to say, well, the base is negative 1 and the height is 3x. So we have negative 1 times 3x, or 3x times negative 1 is simply negative 3x. Then we proceed to the next section over here, and we have an area of negative 1 times 3, which is negative 3. And don't forget the x, so this should be really negative 3x. And lastly, we come up with the area of this particular section. So we have negative 1 times negative 1 becomes positive 1. Okay, so notice that we can say that the area of this entire square is indeed given by the sum of the areas of those four sections. So we can say that the area is also 9x squared, given this first section, minus 3x, given this other section, minus another 3x, given this other section, plus a 1, given the last section in there. Now, at this stage, all we have to really do is to simplify this expression by combining like terms. So notice that this is the only quadratic term. We're going to leave it as 9x squared. Then we proceed to analyze the linear terms, which in this case, we have two of them, negative 3x and negative 3x. And once we combine them, they become negative 6x. And then we look at our constant term, which in this case is simply 1. So we're going to add plus 1 in there. So we can say the following to conclude this particular problem. We can say that the area of the entire square is given by this quantity, 3x minus 1, elevated to the second power, which is the same as 3x minus 1 times 3x minus 1 quantities, or more importantly, this can be actually be written as 9x squared minus 6x plus 1. So really, the big conclusion we can say is the following. We can say, therefore, 3x minus 1 quantity squared is equal to 9x squared minus 6x plus 1. Let's go ahead and box that solution. And that's how we can actually find the product of that polynomial times itself in this particular case. So thank you for watching and have a wonderful day.